You know the chatbots we all use today? Have you ever stopped to wonder what comes next? What if, instead of just programming an AI, we could actually grow one? We're about to dive into a blueprint for an AI that isn't static. It's a living, breathing ecosystem that evolves, adapts, and literally grows itself smarter. All right, let's just jump right in. On one side, you've got your traditional chatbot. It's pretty rigid, right? Its logic is programmed, its tools are fixed. It basically just does what it's told. But on the other side, we have this evolutionary AI swarm. And this is a whole different ballgame. Its logic is self-developing. And get this, it doesn't just use tools, it builds its own. This is a fundamental shift in how we think about AI. So, the big question is, how do you even make that leap? How do you get from a static program to a living, thriving digital ecosystem? Well, it turns out it's less about writing perfect code line by line and way more about creating the right environment, an environment where digital life can emerge, compete, and improve all on its own. And it all kicks off with phase one, unleashing the swarm. And you know what sparks this whole thing? A single request from a user. That's it. That's the trigger that brings this entire evolutionary process to life. At the very heart of this operation is something called the orchestrator node. Seriously, just think of it as mission control, or maybe the quarterback of the team. People often use frameworks like LangGraph to build this part. It gets your query, and its one job is to instantly create and deploy a whole team of agents to tackle your problem from a bunch of different angles, all at the same time. And that brings us to the solver agents themselves. Now, this is key. It's not one AI working on your problem. No, it's a whole team of them. They all get the exact same prompt, the same challenge, but each one is given a slightly different personality or a unique strategy. So now they're all in a race to find the best possible solution, all in parallel. This is where the magic of mutation comes into play. And yeah, it's pretty much the system's version of DNA. The orchestrator deliberately injects variation into each agent. One might be told, hey, you, be incredibly creative. Another gets the instruction to be strictly logical. And a third one might be told to be Socratic, questioning every assumption. This diversity is the absolute raw material needed for evolution to happen.
So with all that beautiful diversity, all these different solutions floating around, we get to phase two, survival of the smartest. Once you have a whole swarm of agents all generating different ideas, you need a way to pick the winner. This is where digital natural selection really kicks in.
And who's the selector? Well, it's another specialized AI, of course, the judge. This agent has only one purpose in its digital life, to be the ultimate, impartial critic. It takes all those competing answers from the solver agents and just ruthlessly evaluates them against super strict metrics for accuracy, safety, and overall quality. It doesn't have an opinion, it just finds the one true survivor. And this all happens in a super rapid cycle. First, the agents execute, racing to create solutions. Second, the judge evaluates all of them. Third, it selects that single best answer. And finally, that winning response is delivered straight to you. But, and this is a huge but, the process doesn't stop there. And this brings us to what is, for my money, the most powerful part of this entire framework. Phase 3, where the AI literally rewrites itself. Because look, getting one good answer is nice, but learning from that success to permanently get smarter, that's the real magic here. So here's how it works. The system identifies the winning agent strategy, that little mutation that led to success. It then extracts that winning piece of logic, and then it rewrites its own core programming, its master prompt, to automatically include this better approach. Finally, it stores this new best practice in its long-term memory, which permanently upgrades the baseline intelligence of the entire system. Okay, but what happens when the problem is something totally new? When none of the agents actually have the right tool for the job? This is where this whole framework goes from being really interesting to truly incredible. This is the wild concept of autonomous tool construction. The AI recognizes it has a gap in its abilities. So what does it do? It literally writes, tests, and validates its own code, its own Python script, to solve the problem. It runs the code in a secure sandbox to make sure it works, and once that new tool is proven, it's saved to a shared library for all future agents to use. Just think about that for a second. It's not just using tools, it's actively expanding its own capabilities. So, what happens when you let this cycle run, not just once, but millions and millions of times? The result is an AI ecosystem that genuinely grows and improves itself day in and day out. And the outcome is a system that just naturally optimizes itself. Over time, all the inefficient traits and the slow strategies, they just get outcompeted. They die off. What survives and thrives are the agents that are the fastest and the most accurate. The system, by its very design, just gets better and smarter. So if there's one key takeaway, it's this. What we're looking at is an AI that isn't just programmed, it's grown. It literally gets smarter with every single interaction, and there's no human coder required in the loop to make it happen. And that leaves us with one final, pretty fascinating question to think about. If an AI can truly evolve, if it can identify its own weaknesses and then literally build its own tools to overcome them, what problems are there that it can't eventually learn to solve?